So today I am going to tell about dielectrics. So dielectrics are the major role in engineering applications. Dielectric materials, magnetic materials and nanomaterials are one of the engineering applications. So that now I would like to tell about the introduction of dielectrics. So my dear students, dielectrics are insulating materials or non-conducting materials. So here the non-conducting materials are placed in the parallel capacitors, then it exhibits the property of polarization. So the polarization is one of the property of dielectric material. So which exhibit the dipoles and also produces the polarization. So this is a major important property of the dielectric materials. So here dielectrics are insulators or non-conducting ceramic materials, so which are used in many important applications. So what are the important applications? Capacitors, memories, integrated chips and sensors. So nowadays this is the major role in world. So whenever and wherever we are going to the industries or companies, so we are going to check the application. So here the capacitor is the major role in many important applications. So that is one of the important application of dielectric materials. So why? Because we are not using dielectrics directly. So which is used in capacitors, then we can use the applications. So that the property of electrical polarization which exhibit the dielectric materials. So this type of materials are called dielectric materials. So my dear students, the dielectric materials are used in many important applications. So that is for electrical insulation to sensors and circuit components. So here, who is the great scientist? The Faraday introduced the property of insulating materials when placed in two parallel capacitors. So these materials are called as dielectric materials. So first one, electric dipoles. How can the formation of the electric dipoles? So here, when the current produces by using positive charge and also negative charge. So dipole is the major role in dielectric materials. So coming to electric dipoles. So first one is electric dipoles. So what is the first property of dielectric material, my dear students? Electric dipoles, right? So dipole means the combination of positive charge, and negative charge. So this is called as electric dipole. So the separation between positive charge and negative charge, that is smaller. So that the dipole moment mu equals to Q into R. So which is known as electric dipole moment. The separation between the dipoles, one positive charge and negative charge, which is called as electric dipole moment. So this is another property of dielectric material, electric dipole moment. Right? So dipoles means the combination of positive charge and negative charge, which is called as electric dipole. So dipole moment means the separation between positive charge and negative charge, which is called as electric dipole moment. So what is the notation for dipole moment? U equals to QR, right? U equals to QR. So where U is called the charge of the positively charged particle and negatively charged particle, and R is the distance between positive charge and negative charge. So where is coming to electric field intensity. Where is coming to electric field intensity. So this is another property of dielectric material. So here electric field intensity means the force per unit positive charge. The force per unit positive charge is called as electric field intensity. So here what is the notation? Capital E. Capital E means electric field intensity. So E equals to Q by 4 pi epsilon R square. So what is the formula for electric charge. So how many lines? How many electric lines passing towards the positive charge or negative charge? So which is called as flux or electric displacement vector. So here D is directly proportional to capital E. So my dear students, capital D. So capital D is directly proportional to capital E. So D equals to some constant of proportion of epsilon naught into capital E. So capital E equals to epsilon naught. What is the value of capital E? E equals to Q by 4 pi epsilon naught r square. So epsilon naught gets cancelled. So that capital D equals to Q by 4 pi r square. So this is called as flux density or displacement vector notation. D equals to Q by 4 pi r square. Right? So here, so in today's video, so you learned what is dipole and what is dipole moment, what is flux density and what is electric field intensity, and who suggested dielectric materials and what are the important applications. So I have concluded like this in this video. So if you like this video, please like, share and subscribe my YouTube channel. Thank you.